How are you all? Avyukt, how are you feeling?
Yeah, feeling better now.
Feeling better? Okay, good. Give me a minute, guys. Just see. Okay, where are we on the homework? Let me see what did I have for you guys. I don't know. Suddenly my thing stops working. Algebra 2, geometry. Okay, guys, did you have any questions on the homework?
I had questions on the homework for part
You,
5.
you had?
Mm, yeah.
Oh, sure. Okay, so you had 4, 5, 6. Okay, Johan, did you have any questions?
No.
Mm-hmm. Which one, Avyukt? This one?
Part 5.
Sorry, Avyukt, what was that?
Part 5.
Part 5. Mm-hmm.
For one. Yeah, but I understood what you were doing, but if they weren't parallel, how could we do that?
Where am I? Which one?
For number 1, 2, and 3.
Oh, okay. The figure is definitely incorrect. They should have been parallel. Makes sense?
Okay.
Um, it doesn't matter as long as, okay. Why it did not matter here as well, I'll tell you, Avyukt.
Okay.
Even if they're not parallel, right, Avyukt?
Yeah.
They did not say alternate interior angles are equal. They did not say that these two are equal. They just wanted you to classify the angles. They are still alternate interior, correct?
Yeah.
But don't, if they're not parallel, you can't say 2 equal to 7. Got it?
Okay. Yeah, makes sense.
Yeah. Anything else?
No.
Okay. Anybody, any other questions? Ishita, Prisha, Ishita, I forgot to ask your sister to come for the Algebra 2 class, ma. Please tell your dad from next week she can attend, okay? Make sure you tell her.
Okay.
Okay. But, oh, Ishita, you wanted geometry, yeah? Not Algebra 2?
I'm in algebra 2.
But you wanted Algebra 2 class, right?
Yes.
This class is geometry, right? See, I
Uh,
got confused. Yeah. So where did we get a mistake on the time? I don't know, but I think you mistook the time. Can we attend from next week?
yes, ma'am.
I can share the recording for this week too, but you can attend from next week. Is that okay, ma?
Yes.
See, I know, meaning, I don't know from where we mistook the time. Did I say the wrong time? I'm not sure, but I did not confirm with your dad at all. So that's why I was thinking, hey, I did not invite you for the class, I was thinking. So that's where I will check, okay? I did not send the welcome email yet to your dad as well. But there is some mistake. Can I check it after the class?
Yes. When is the algebra 2 class?
Just
ma'am?
1 hour before, ma.
Okay, thank you.
The class that ended was Algebra 2. I'm sorry about it, but I'll talk to your dad. I don't know where is the mistake. I have not sent the welcome email as well to your dad.
Okay.
Okay, I'm just jammed. Okay, so I thought of doing it only this weekend. Tell him.
Okay.
Okay, maybe I told the time incorrectly, or I will check wherever the mistake is. Got it?
Yes.
Thank you, Ma. I really appreciate it. That's
Thank
why
you.
I'm glad I asked you immediately.
Yeah.
Bye, Ma.
Bye.
Okay, any other questions, guys? Can we move on? Okay.
Yeah.
Did we discuss last week about dilations? Did we discuss last week about dilations? Hey, guys, you please tell me, guys. Did we discuss about dilations?
No, I don't think so.
Okay, thanks. HSDX. Okay, dilations, unit 4. Okay. Let's go ahead. I really want to start with dilations. Let's see. I don't want to start with translations. Let me go ahead directly to dilations first, okay, and then come back. Rotation, rotational symmetry. I'll do that all later. But I want to go to dilations and come back to here. 1 second. Now. So, okay. So now, I don't know how we studied early in 7th grade. Okay, let me share the screen. Let's come here. Okay, we are going to discuss transformations. Okay. When it comes to transformations, do you know what are the transformations that you study? Meaning, you will be given a pre-image. Okay. After transformation, what does it become? Guys, do you remember what pre-image will become what? Let's say there is a triangle. There is a triangle like that. Let's say there is a triangle like this. Okay. There are 3 actions you can do, right? Flip, turn, flip, turn, slide. What are the names of these transformations? Who can say that?
Reflect.
Which is reflect?
Flip.
Flip. Good job. This is reflection. Then
And turn is rotation.
rotation. Then
And slide is translation.
good. Okay. Suppose if you flip or turn or slide this. Let's say you slide this to here. After this is my pre-image. What is this called?
The image.
Image. Good job. So that becomes the image. Okay. Now, as a layman, who I don't know what is transformation. So I will call it flip turn slide. Now that you are in geometry, you will all be calling reflection, rotation, translation. You know that. Now, these all we studied already in 7th grade. Now, other than that, we also studied one type of transformation where you either made your original triangle this or your original triangle was made this. What is the difference? Meaning, what is this transformation?
A dilation.
A dilation. But there is a huge difference between this set and this set. What is the difference between these two?
Well, for like the reflection, rotation, and translation, all you're doing is moving the image, or like flipping it, turning it, or sliding it. But for dilation, you either make it bigger or smaller.
So what happens? Here it becomes bigger or smaller. If it becomes bigger, what is it called?
An enlargement.
Enlargement. If it becomes smaller,
Reduction.
reduction. You always use a factor, right? You always use a scale factor. How is the scale factor in reduction? How is the scale factor in enlargement?
For enlargement, it's greater than 1. For reduction, it's less than 1.
Less than 1. If it is equal to 1, what happens?
It stays the same.
True. But where does it happen? Here, guys, the scale factor is always equal to 1. That is why your pre-image and image are congruent. Pre-image and image are congruent because the scale factor is equal to 1. How are the pre-image and image in dilation? Pre-image and image are they congruent?
No.
Prisha, what do you think here? This became either this or this. What happened? They are same shape, but not the same size. So what happens? They are, what is the other peer definition for congruence?
Similar.
Similar. Same shape, different size is similar. Same shape, same size is congruent. Any questions for me? Did you guys get an intro now? Meaning the same intro that we studied in 7th grade is what I reanalyzed. So basically in transformation, you can either translate, rotate, reflect. In dilation, you can either enlarge or reduce. The scale factor is greater than 1 or less than 1. Pre-image and image are similar. Pre-image and image are congruent. Scale factor is equal to 1. Now the thing is, when it came to a translation is a little easy. Don't worry about it. Coming to reflection, about what you will reflect, about what you are reflecting, about what will you reflect? Let's say I have a triangle like this. About what you will reflect it? About what you can reflect a pre-image.
About the x-axis or y-axis.
True. What is it called? It need not be x-axis, y-axis. It can be what is this? It can be about this line or this line. It can be about any line. So what is required for that reflection? Line of reflection that is required for reflection. There has to be a line that acts as a mirror. For the rotation, what did you need? If you want to rotate an object, what is that point you want? See, this triangle, if you want to rotate it, let's say it becomes this triangle. What did you do? You rotated about what? What did you need? You needed see, it's like holding the bar, like holding a rod like this to that. This is the center of rotation, okay? All the vertices were connected to the center of rotation.
Oh, wait.
And
Is it about the origin?
yeah, what is that? You needed
Is
a
that a
point.
reflection?
Illama. I think we are confused. Okay, let's go back. What I'm saying is, you have a triangle like this, okay? Now, I am making that triangle like this. Okay. Basically, I rotated it, right? Either clockwise or anti-clockwise. But what did I do? I had a point called center of rotation. So how did I rotate it? How did this rotation work? Just don't memorize formulas. Understand what is going on. This was my pre-image, right? So I had the center of rotation as the origin and I drew a line to every vertex. Okay. Now, if I say, hey, rotate by 180-degree clockwise, if I ask you this, right? Every line you rotated it and then rotated it 180 degrees. And then you measured this distance and marked it here. Does it make sense, guys? Okay, let me redraw it properly. Nice figure. Let's see. Okay, you have this diagram. This is my triangle. I'll show you nicely. But I don't want the origin. Let's say I have it here. Okay. I don't know. I just want you to understand. I'm not looking at anything else. Okay. So here, the 3 vertices, I have these lines. Okay. Now I want to rotate it 90-degree clockwise. What did I do? Meaning, I know we all memorized some formulas that I don't want to do. I want you to understand what's going on here. A, B, C. How did you rotate it clockwise? I considered my point of rotation as the origin. Point of rotation as the origin. I drew lines. Okay, I imagine those as bars. 0A, OA, OB, OC. Now, each line OA, OB, OC, I rotated it 90-degree clockwise. Let's consider OB. I consider first OB. Now, this became B dash. On B, I measured this, how much is it? And I had a point here. So that is OB. So B dash is here. Okay. Now again, what I did, A line, right? This one, I rotated it 90-degree clockwise. I rotated it 90-degree clockwise and placed A dash here. Okay. The next thing what I did was, I took this OC. Again, I rotated it clockwise 90-degree and then placed C dash here. Now I connected A dash, B dash, C dash. You know, I connected A dash, B dash, C dash. It should have been a little better. The diagram is not correct. So it should have been like this basically. It should have been like this. It should have been like this. So here, you see, this is how I rotate the figure 90-degree. When you look at it, this was a standing line. This became a sleeping line. This was a sleeping line BC. It became B dash C dash, right? It became a standing line. The hypotenuse was this, it became this. So when you rotated it clockwise, this is how you rotate it. So you needed a center of rotation, which was all the point of rotation, or point of rotation, which was always the origin. Similarly, for reflection, you always needed a line of reflection. Any questions? Any questions? Okay. So what are you going to do in geometry? A fresh year learning transformations once all around again once more, right? There's a lot that we are going to do in transformations in geometry. The symbols that you use to show your transformations, all that stuff is going to differ. This is going to be more complicated. And the later part, in later stages of transformation, we will also learn composition of composite transformation. Composite transformations means 2-3 transformations together. 2-3 transformations together we will learn. And yet another thing is, you had always had center as your point of rotation or the center of dilation. You were always having the origin as for dilation, that is the center of dilation. For rotation, you will always have that as your point of rotation. However, in geometry, we will move that to some other point and then we will consider transformations around any point. Transformations not just about origin, but about any point, or reflection around any line, about any point or line. So these are the changes that we'll do. And symbols that are used for composite transformation, meaning if you want to do 2 transformations, how to represent it in proper symbols. All this will come in geometry. Any questions for me? This is what you're going to study. Can I move on? Okay. So we had a very basic review of transformations, right? So now let's see. Okay. Suppose, okay, you all know the dilation always had a scale factor. Okay. Now let's say I had, this is my circle, this is my triangle. Okay. This is my triangle. Center of dilation is my origin. Center of dilation is my origin here. Okay. This is A, B, C. I want to dilate it by scale factor of 2. What did you do, guys? Let's say this is 1, 1. This is 5, 2. This is 3, 6. Let's say these are the 3 vertices. Now, I want to dilate it by a scale factor of 2. What did you guys do in 7th grade? What did you guys do?
Multiply each point by 2.
Multiply each side by 2. But why? How did you get it? Did you understand how you dilated it? From origin, you drew from the center of dilation, you drew straight lines to the vertices. This is the understanding I want you to get. If you had not understood it before, I want you to understand how you dilated it. You drew lines like this. Similarly, through every vertex you need to draw from the origin point of dilation, center of dilation, you will draw these 3 lines. Now what do? You will measure this distance, the original 0C distance, multiply that by 2. So multiply that by 2 and then on the same line, mark that point which is twice the distance. So that becomes C dash. Now on the line OA, which was extended, measure OA and twice that you're going to put it as A dash. Because scale factor is 2, right? 2 times I'll measure. So from O to A dash, it is twice of OA. O to C dash, it's twice of OC. Similarly, on the line OB when extended, right? You're going to measure what is OC and twice of that I'm going to measure and put it as B dash. Any questions still here? Now connect A dash, B dash, C dash. I get my dilated triangle, which is the image got after the dilation. Instead of doing this, instead of understanding this, the easiest way for us was 1, 1 was given. I multiplied it by 2, so this became 2, 2. This became 10, 4. Just multiply each by 2, 6, 12. This is what we did, right? Instead of finding these points, I want you to understand what does dilation means. What does the center of dilation do? Because why am I explaining this now? Because we are going to shift the center of dilation to some other point. So which will totally confuse you. Till date, we were not very clear what does the center of dilation did. What did it do? Basically, that was the pivot around which we were dilating. You see, that was a pivot. That was a main important point from where you drew a straight line to each of the vertex. And if it was a reduction, you halved that or doubled it, whatever was the scale factor. So on that line itself, you plotted C dash, A dash, B dash based on the scale factor, and then connected our A dash, B dash, C dash to get the dilated triangle, right? So how is the center of dilation important? That was the main point from where we drew all these lines. In geometry, we are going to move the center of dilation to some other point. So what would happen? The way you start dilating will be around some other point, not that same origin. Origin was so easy. You just multiplied it by 2. See, you just multiplied each by 2 and got it. But if you move the center of dilation to some other point, right, what would happen? What changes should we do? From A, we will draw that line to center of dilation. From B, we will draw that line to center of dilation. Similarly, from C, we will do this. Okay, now if we want to dilate it twice, we'll extend the line. So now B dash will become this. C dash will become this. A dash will become what? Here somewhere. Now you connect A dash, B dash, C dash. Now A dash, B dash, C dash is a dilated triangle with a scale factor of 2 around this point. Does that make sense, guys? Okay,
Yeah.
but yeah, I have not told you what happens numerically. Before in 7th grade, when you dilated around origin, it was so easy. Multiply by 2, multiply by 2, multiply by 2, multiply by 2, multiply. That's not going to happen here. It's going to be a lot more complicated because center of dilation moves. So you need to understand first of all, geometrically understand what's happening. From the center of dilation, I'm extending the points. That is what geometrically it happens. But how to find out these coordinate points is what we are going to see now. Any questions? Any questions? Okay, let me go there. Okay. How about this? Okay. Let me go ahead and give you this directly so it's easy and then I'll explain what happens. Oh my God, I'm sorry, guys. 1 second. I want to give you this directly. Okay, usually I don't give you this directly, but I feel like giving you. Let's see. So we are going to, oh, sorry guys, give me a minute. I am lost. Okay, so for dilation, yes, Savyut, what is your question? I'm listening to your question. Go ahead.
Could you show me how to get the points for rotation?
That is later. First, let's do the dilation piece. Is that okay?
Yes,
Yeah,
sir.
definitely we'll explain one by one, okay? But for now, let's do the dilation piece, okay? How about this? This is what we are going to do. Can I erase everything? You understood geometrically what we are doing. We are just moving the center of dilation. From there, that is our pivot point. Okay, from there we are dilating it. Now let's see this one. Geometrically, what would happen? Okay, let's see. Suppose my center of dilation, I'm going to change from 0, 0 to A, comma B. Okay. No longer my 0, 0 origin is going to be my center of dilation. I'm going to move it to a point A, comma B. When the center of dilation is 0, comma 0, it's very easy. You just multiply the scale factor to x and y, you get your transformed points. Here, when your point of dilation is A, comma B, it's never going to be the case. This one was easy. This is what you learned in 7th grade. Now your center of dilation became A, comma B. So let's say this point moved from here to this point 1, comma 1. Now what happens? First, what you need to do, x, comma y is your point, right? First, what you need to do, first, you will find the distance between x minus a. See, a, comma b is your xy point. Okay, point of dilation changed to x, comma y. So first, you will find the distance between the center of dilation and your x point. You will find the distance between your center of dilation and your x point. That you will multiply with the scale factor. Okay, why you can't do here? This A was your origin. So directly you multiplied with K. What is that you need to multiply with K? The distance from your center of dilation to your point. So x minus A is the distance between x and A. That you're going to multiply with K. Now, you got your dilated distance that you're going to add it to your center of dilation. This is for the x coordinate. Then for the y coordinate, what you will do? First, you will find the distance between your center of dilation and your y coordinate. Multiply that by k. Whether it is reduction or enlargement, same thing. But then this is your reduced or dilated distance for the y. However, from the origin, meaning this was the center of dilation. So you will add that to b. Make sense? So this becomes your transformed points if the center of dilation is A, comma B instead of 0, comma 0. Johan, are you with me?
Yeah.
So what will you do? Again, I'll tell you. Your center of dilation changes to A, comma B this year. Okay. In this case, to find out your transformed coordinates, I'm going to find. How do you find? Don't memorize the formula. Understand how it is done. First, you find the distance, x, comma y, right? Meaning that is the point which you have to dilate. So first you find out the distance x minus a and then you multiply by your scale factor. Okay. This is your dilated distance, whether it is enlargement or reduction, whether it became half or double, this is your dilated distance that you're going to add it to a. Any questions, guys? Similarly, for the y coordinate, first you find out the distance and then you're going to multiply it by the scale factor. Then you're going to add it to your center of dilation. This is the transformed point if your center of dilation changed from origin to A, comma B. x comma y point will become this comma this after a dilation by a scale factor of k, provided your center of dilation is a comma b. Shreya, are you with me, Shreya?
Yeah.
Okay, now let's go ahead and do this one. Okay. Yes, this is just for you to do what, meaning, let's see. It's an easy one though. It's just plugging in values. What is going on? I'm trying to, oh, my cursor was way down. Graph triangle ABC. Guys, it is just enough. After, oh, no. This one you all know. Please, no, not this one, please. I didn't mean to give you this at all. Okay. How about this? Yeah, the center is very easy, guys. You all know it's very easy. Graph quadrilateral KLMN to K dash, L dash, M dash, N dash with these vertices K, L, meaning I want the new vertices to be K dash, L dash, M dash, N dash. I just need the coordinate points K dash, L dash, M dash, N dash. After you dilate around 1 comma 2, the center of dilation is different now, not the origin. And the scale factor is 1/3. So it will become smaller. Now I'm going to bring the book. Okay, there are multiple books that I want to refer for transformation. Okay, it is not just one book. Just one book does not cover what we want. Okay, for transformations. Let me bring that. The book does not discuss anything. Um, and when the image in, okay, go ahead and do this. Go ahead and do this. I really want to cover a little bit more on something. Let's see.
So are you gonna see the picture through our camera?
Oh, no worries. You can just send me the coordinates, Amma. Just send me the coordinates.
Mhm.
That is enough, right? Makes sense, huh?
Yeah.
Translation. Yeah, I also want to cover basic reflection, basic translation things. But that is not enough. Let's see. Um, one second, guys. Did you all get it?
Yeah.
If you had followed the class, you should be able to do otherwise as well. I'll help you. I'm checking your answers now.
Yeah, you want us to dilate all 4 points, right?
Yeah, ma, all the 4 points. Then only I'll know that you understood, right? I will not cover more of this. That's it. Meaning dilation is enough if you know how to dilate it around some other point. We want to go ahead with notations and translation. How will you? There are some notations that are so different, and we want to work on similarity transformations, which is based on dilation, and composition transformations, which is 2, 3 together. That makes it a lot difficult. I don't know how to check your answers. Where is it? Shreya has the answer. Where am I to check the answer for? Yeah, I have it here. Oh wow, Shreya, good job. Avyuk, what are you doing in Shreya? What are you doing in school? No, Avyuk, that's not right. Dhruv, Dhruv. I feel like N dash is incorrect. Shreya, what are they doing in school, ma?
So we just had like a test on constructions and like parallel and perpendicular lines. And I think we're starting transformations next.
Oh, that's nice. Okay. So let's try to finish at least. This is my target. I really want to cover the basics of translation, reflection, rotations. Now I've shown you how to dilate around, not the origin by some other point, right? So I'm going to go over again rotation, reflection, translation, rotational symmetry, reflectional symmetry, and then see these are just reviews, right? So and I'll also go through uh, the notations today. Okay, so that way we can just cover composition transformations next week. Johan, something feels not right. 10414. Johan, N and K are not correct, Amma.
Okay.
Okay. Avyukt, somewhere something is missing. I'm going to explain it to you. Ashrita, did you send it, ma? Yes, you got it right. You got it right. So, one easy way is to use the formula. I know that, but I don't want you to memorize formulas. You should really understand what's going on. But here, see, scale factor is 1 by 3. A comma B is 1 by 2. That's I'm sorry. That's the center of dilation, right? This is what I would do. Now, x comma y will become what? First, you need to find the distance, multiply by k, add a. Similarly, for the y coordinate, k times y minus b plus b. So it is just plugging in values, guys, here. So 1 by 3, x minus a means x coordinate we don't know, minus 1 plus 1. Similarly, 1 by 3, y minus b is what? 2 plus 2. Right, guys? You know what? I'm out of charge. 1 second, guys. Guys, I have to go get the charger. Okay. Anyway, let's see. Here we go. After this, we know these are my points, right? So first, K point. What is X? Minus 2. What is Y? 8. It's just plugging in, right, guys? 1 by 3 times minus 3 plus 1. It is minus 1 plus 1, which is 0. 1 by 3, 8 minus 2 is a 6 plus 2. So this is 3 2s are 6, 2 plus 2 is a 4. So K dash point is 0, 4. Any questions? Any questions? Pratika, did you get it? Dhruv, did you get it? I didn't get your answer, Dhruv.
Yeah, I got
I sent it, but you said it was wrong, so I was fixing it.
But did you understand now, Dhruv? I
Yeah.
do see.
Yeah.
Okay, but can please, I did not get correct answers. Avyukt, can you work on M and N points. Johan, can you resend M and Johan got it right. You corrected it, Johan?
No, I didn't. I didn't correct it yet.
You didn't correct it. Then I feel like now you have gotten it right. Let me see. Yeah. M and N and K. Can you all correct your N and K? I will give you the answers. K dash I gave you. L dash I'll give you 1,4. Okay. M and N I want you all to get it correct so that I can move on to the next one. Prisha, I'm waiting for your answer as well. I'll quickly go get the charger. Okay. My daughter took it and went. I had it here. I'll bring it and come. You get it? Can I try? If you want me to try, you have to let me know, guys. Or you should know how to.
Priya, can you check my answer?
Yes, Pratika, I am here. Pratika, M and N is what I wanted, right? Oh, you gave me your saying? Correct. 2, 3. Let me see. Let me see. Give me 1 minute. Ziranka. Pratika, the y value of the n coordinate is alone a problem. Other than that, everything is correct.
Okay.
Y coordinate of the n dash.
Okay, let me change it.
Priya, I changed my answer.
Yeah, you got it. Okay, you corrected it. Let me check. Let me check. M prime is 2,3. Yeah, correct. Okay, Johan, I think you got it. Okay. If you just let me know 1 or 2, it's enough, guys. As much as I understand you got it, I'm fine. Prisha, that is correct, ma, but n is incorrect. And y coordinate of the n is incorrect. Can you fix it? The same problem. I don't know. Pratika and Ananya, y coordinate of n is incorrect, guys. And the same mistake. Both of you have written a -1. Can you check? Prisha, that is also incorrect. Y coordinate of n. Can I do the y coordinate of n, guys? Yes, Avyuk, that's correct. Y coordinate of the n, I don't know. Everybody is making a mistake. Why? Y coordinate of the n. So let's see okay, I'm going to do only the y coordinate of the n. Okay, now 1/3 plug in y minus b, y, right? Minus b is what? -2. And then again a -2. So what happens? 1/3 times -3 -2, right? -1. So will it not be, I am getting it as -3. Y coordinate. This is a +2. Hold on. B is a +2, right? So what happens here? -1 plus 2 is a +1, ma. What did you all get?
I got that after I redid it.
Fixed it. Okay. Ananya, did you get it? Prisha, did you get it? It's not a -1, right, ma?
Yeah, I got it.
Okay. Prisha got it. Ananya, did you get it?
Yes.
Okay. Can I move on then? So dilation about a point that's not the origin is something you have understood. Can I take it like that? And now, guys, I forgot to tell you actually, translation. I'll come back, okay? I'm going to revise each of this again. Reflection, rotation, right? So coming to these three, right? What is this called? Just because the pre-image is congruent to the image, it is called something. What is it?
Rigid motion.
What I'm asking is, what type of transformation is it? Whereas dilation is not. So what type of transformation is that? What type of transformation is this? Okay, let me write it down. What is this? Why is it called like this? What is that? Why is it called like that? Why is it called like that, guys? You tell me. Why is it rigid transformation? Why is the other one not rigid transformation?
The one on the top is rigid because it doesn't change size.
Yep, they are called rigid transformation because the pre-image and the image are of the same size. They're not going to change in their size. Same shape, same size. Whereas similar figures, pre-image and image and dilation are going to change their size, right? Either it's going to increase in size or decrease in size. So they are going to be called non-rigid transformation. Okay, rigid transformation, the best part is it is going to, rigid transformation will preserve both the size and the shape. So there is congruence between image and pre-image. Whereas in non-rigid transformation, they won't be preserved, meaning the shape will be preserved, but the size will not be preserved. Make sense? Did you guys get it?
Yep.
Yeah.
Okay. Now, isometry means what? What is isometry? Have you heard of the name? I don't know whether, okay, if you have studied 7th grade with me, you would have heard it. Isometry means what? Iso means same measure. Same measure. So isometry is preserved in which type of transformation? Which type of transformation preserves isometry?
Rigid.
Rigid transformation preserves isometry. Why? Same measure between image and pre-image, right? So rigid transformation preserves isometry. Good job. Non-rigid does not. Okay. And then what else I wanted to tell you? Okay. Let's say, okay, how about this? I really wanted to, how about this? Okay. Coming to, let's say, orientation of vertices. Orientation of vertices. I really want you guys to think about it and tell me. A, B, C. When I translate it, it becomes A, B, C. Orientation of vertices means the order A, C, B, right? A, C, B remains as A, C, B. You can go clockwise or anti-clockwise, doesn't matter. In pre-image, if you go clockwise, you go clockwise in your image. In pre-image, if you go anti-clockwise and check in your image. So orientation of vertices is preserved in translation. Okay. Can you tell me what happens in rotation? If you rotate it, will the orientation of vertices be preserved or not?
No.
Did you draw and see? Tell me.
Yeah, I don't get that part.
Orientation of vertices. Orientation of vertices means order of the vertices, ma. See, order of the vertices. Let's go clockwise. A, C, B, right? When you move this figure right or left, right, the orientation of the vertex never changes. Start from A. Go in a clockwise direction. It's A, C, B, right? Here, after the movement as well, it's A, C, B, right? That is orientation of the vertices.
Oh, okay. So it
Makes
doesn't
sense?
change.
It
Yeah.
doesn't change in translation. I am asking orientation. We are discussing orientation of the vertices, right? So we said translation preserves it. Translation preserves orientation of vertices, right? I'm asking rotation, reflection, what does it do?
Oh, okay.
Will it preserve it or not preserve it? What I would do to find out, I will draw a figure. I will rotate it like this. I will write A, B, C. After rotation, what happened? Okay, like this I will draw and check. Write down the order of vertices. Let me go anti-clockwise now. Again, I will start from A only. What happens? A, B, C. Is it preserved in rotation?
Yes.
It is preserved. In reflection, what happens? These are things that you try to understand for understanding purposes. You have to really understand transformation and study. Then, however, whatever questions they ask, you'll be able to answer. Okay, you don't have to study if I directly give you formulas. I don't want to give you formulas directly. How about this reflection? Reflection is the orientation of vertices preserved or not?
It's not.
Yeah.
What, guys? Yes, no? All of you are saying some different answers, right? Try. I'm okay to wait. Think and tell me. You figure it out, you will remember forever.
Wait, should I say it out loud or should I?
Yeah, say it out loud, ma. It's just an interaction. Go ahead.
I don't think it's gonna be preserved.
You
'Cause
think so?
I drew it out and then it went opposite directions.
That's true. A, B, C. A line of reflection is here. I flip this. When I flip it, what happens? I flip it like this, meaning here. I flip it. Okay. B comes here, C comes here, A comes here, right? That is what is reflection, right? Now write the order. I go from A, anti-clockwise. A, B, C here. I go from here. A, C, B. Did you get it? So it's not preserved. Make sense?
Also, if you go clockwise for both, it's not preserved.
However you go, whether you go and see, if you go clockwise in your pre-image, go clockwise in your post
Okay.
image.
Okay.
If you go anti-clockwise in this, go follow the same rotation.
Okay, yeah, we have to follow the same thing.
Yeah, same rotation, that's all.
Okay.
Okay, even if you go, okay, the other way, let's see Ashrita for you, ACB, right? What happens? You go anti-clockwise, right, Amma? A, B, C. Do you see it?
Yeah.
So it's not the same. ACB became ABC, which is incorrect. You got it?
Mm-hmm.
Okay. Isometry and orientation of vertices is the two different things I've said. And congruence is preserved in rigid transformation, that is not preserved in non-rigid transformation. Okay. Now what else? Give me 1 minute. I just wanted to. Okay, good. Okay. Now, let's move on. Okay, I really wanted to go ahead and show you the notations that are being used. That is a little tricky. Let's see. How about this? We are going to discuss all the four. How about this? What is this, guys? Okay, till date, you have not been introduced to these notations. Let me go and describe. Okay, first, we discussed dilation, right? So what is this? Can one of you tell me, describe this? What does this D stand for?
Dilation.
Dilation. What does this O stand for?
Origin.
Origin.
Yes, center of dilation is origin. Center of dilation is origin. What does it K stand for?
The scale factor.
Yeah. Any questions? So this is a notation we'll start using. This means please dilate the xy point around origin with a scale factor of k. Any questions? Now, I want one of you to explain. Let's go to translation. What does this mean? Translation is the easiest. That's why I don't describe that much. Go ahead.
What did you want us to say?
I want meaning what does the symbol say?
Translation.
Translation of what? Translation of what? What is the original point? Translation of point. What is the
A.
point? Huh?
XY.
Yeah, xy. Translation of point xy. How? How? A is the transformation. A is the movement applied to x. B is the movement applied to y. Make sense? So we will refer that as TA comma B. That means x has to be translated by A. It can be negative or positive. Negative means you move left. Positive means you move right. I'll give you an example as well. Okay. Now, if I give you this, let's say I'll give you this. What does this mean? I'm asking you to move the point x comma y to how? You move left by 2 and up by 3. Did you guys get it? Suppose if it's like this, you move right by 2, down by 3. Any questions? Ananya, did you get it, ma? Prisha, did you get it? Okay, we have discussed 2. Okay, now the confusion. Rotation also, yes, Avyukt, what is it?
For the translation, oh wait, never mind.
But you did not ask me something. You know what? You did not ask me this. What is this? I want a bigger notation. Wait, let me see. I can't make it bigger. That's sad. 1 second, guys. Okay, let me write it down. What big deal? Second, where is it? I told you about dilation, but you never asked me for this one. D. How about this? What is that? This one we discussed. What is this one? Any thoughts?
When you have like another center of
Dilation. Good job. The center of dilation now became A comma B and the scale factor was K. So apply dilation given by the scale factor K. Take your center of dilation as A comma B and transform x comma y point. That's what it is. So what will be the formula for this one that we studied now? X minus A multiply by K and add A. That's what it will happen. The points will change like this. And then again, K times Y minus B plus B. Did you guys get it, guys? Okay. Now, the last two will be quick and then I want to tell you symmetry. Symmetry is going to take a little bit time. Let's see. I really want to do. Let's see. Okay. How about this? What is this, guys? There are two R's. Rotation and reflection start with the same R, creating confusion. So how to ward off that confusion? What is smaller? What is bigger? What do you think?
SR would be reflection.
Yep, reflection. This is the line of reflection. That's why I explained what is line of reflection, what is point of rotation. See, if it is rotation, it's around the origin. Do you see? So reflection is indicated by small r around x-axis or reflection around y-axis. So this is the notation we can use. Now, reflection of the xy point around the x-axis will give you x comma minus y. When you reflect it on the when you reflect a point, let's say this is a point 1 comma 1. Think about it. Just now I explained to algebra 2 as well. If you reflect this point around the x-axis, right, what coordinate changes? What coordinate changes?
The Y coordinate.
Yeah, x remains the same, but the y coordinate negates. So if it is like this, what happens, guys? What will be the rule then? After transformation, what will happen?
The line of reflection on the y-axis.
Correct. But what will happen to the xy point? You're reflecting it on the y-axis. Same point, think about it. You're reflecting it on the...
X comma minus y.
Minus what? Minus x comma y.
Minus x comma y. Why, guys? When you reflect it on the y-axis, when you're reflecting a point, 1 comma 1 point, you're reflecting it on the y-axis, what changes, Avyukt? Does the x-coordinate changes or the y-coordinate changes?
The x coordinate changes.
X-coordinate becomes minus x if it is on the y-axis. Make sense?
Yeah.
Yep. So if you're not clear, ask. Okay. Now we talked about this. Okay. I'll talk to you about glide reflections next week. Okay. Glide reflection is slide and flip. Slide and flip means translation and reflection together is glide reflection. That we'll talk about it next week. Okay. But what I wanted to do with you was symmetry, right? Give me 1 minute on that. Symmetry. Yeah. So, how about this? Okay, a rectangle has how many lines of symmetry? Rectangle has how many lines of symmetry?
2.
Okay. How many lines of symmetry does a square have? There is a pattern. How many lines of symmetry does a square have?
4.
Good. How many lines does of symmetry does a regular pentagon have? There's a pattern.
1.
A regular pentagon.
10.
Regular pentagon means all sides are equal.
5.
Good. 5. How? 1, 2, 3, 4. Where did I miss? What did I miss?
It's on the left
5.
side, yeah.
5. Yeah, I think this one. You got it? So 5. How about square? You said 4. Pentagon. How about a regular hexagon? How many lines of symmetry will it have? Regular means all sides are equal. Then only it can be symmetric.
6.
6.
6. Good job. Now comes the harder part. How many lines of symmetry will a parallelogram have? Yeah, parallelogram, correct. How many lines of symmetry will a parallelogram have?
0.
2.
2.
Good, guys. This is what I expected. So which is right? Some of you say 2, some of you say 0. Which is right?
0.
0. You see why, Seema, if you draw a line of symmetry, even if you draw a line of symmetry like this, okay, see what happens. It meaning they won't coincide. See, this obtuse angle cannot fall on an acute angle. Do you see it? This acute angle, when you flip it, cannot fall on an obtuse angle. Make sense?
Yeah.
Okay. So the line of symmetry is 0. Now, I did not talk to you about rotational reflectional symmetry. I know, but let's see. It's not in the homework either. Okay. When the left side matches with the right side, there is a line of symmetry. Are you all with me?
Yeah.
Okay. Now, if a figure can be turned around a point, okay, and lands on itself, then you have point of symmetry. Make sense? So reflection has line of symmetry or point of symmetry?
Line.
Line of symmetry. Rotation has?
Point.
Rotation has? You always rotate around a
Point.
point. So you have point of symmetry. Now, if you're given, let's say, if you're given, okay, if you're given like this, meaning, suppose if you're given questions in your homework like this, would you be able to do? I'm wondering. This is composition. Composition means you have two transformations together. What are the vertices of an image of this triangle? If it is reflected over the line y equal to x and translated right by 2 units, this is straightforward. Straightforward in the sense, You need to know what is the rule for reflection on y equal to x, right? Once you know the rule, you'll apply that, meaning, let's say the point remains as x comma y, right? So if it is reflected on the line y equal to x, what happens, guys? X comma y point becomes what?
Auntie, I have to go now.
Yeah, ma. So we can continue this next week. I'll stop here. I will let you all go. Okay. I'll let you all go. I will give you homework, simple homework. We will see, meaning some notes as well I'll give you for the rules. If you reflect it on the line, what will be the transformation? Apply that to y and x and then translate it 2 units to the right. You should be able to do simple things like this. Next week when you come, we'll talk about glide reflections. Any questions for me?
No.
Okay, guys. See you all next week.
Bye, Miss Priya.
Bye, guys.
I
I miss Priya.
Bye, guys.
Good night.
Good night, ma.